Hello, and welcome to another series of video lectures. This series is going to be about learning Python programming, and it's aimed at people studying the GCSE exam syllabus. So there are lots of different computer languages out there. There's some examples here. The one we're particularly going to use is called Python, and I'll explain why we're using it later on. But of course, there's many other really good programming languages that can be used. So really today is about understanding what a programming language is, how to go about starting to write programs in Python, and starting to think about things like the syntax and how we construct statements that Python can understand. So Python is a programming language. What is a programming language? Well, it's a vocabulary and set of grammatical rules for instructing a computer to perform a specific task. So if we have a look at this little diagram here, we can see that down the bottom we've got the actual physical hardware that's inside your computer, all those transistors and circuit gates and things like that. And then we've got, how do we talk to a computer? Well, computers understand ones and zeros. But humans aren't very good at understanding ones and zeros, so we've built lots of different types of programming language on top of this that we can understand, but that can be converted into machine language, machine code, ones and zeros, very easily for the computer to understand. So the ones at the top are what we call the high-level languages, and then towards the bottom we've got things like assembly, which is a low-level language that you will practice a little bit, maybe at A level, depending on which exam syllabus you're following. So the term programming language usually refers to the high-level programs. And there's a big example here. Some of the more famous ones might be C, C++, C#. You've got things like Java. You've got things like JavaScript as well. Lots of different types of language. Each language has a unique set of keywords, so words that it can understand, and a special syntax, basically grammar rules, for organizing program instructions. A program is just a sequence of instructions that specifies how to perform a computation. And this might be something mathematical, for example, solving equations, or it might be searching and replacing text in a document. Early computers in the 1940s and 50s were usually just carrying out basic mathematical operations. They could just do it a lot faster than people. We can describe programming as the process of breaking a large complex task into smaller and smaller subtasks, and these are the ones we design a solution to, and they work together to solve the big problem. And when we divide big problems into small problems, there's a special name for that, and it's called decomposition. We'll often talk about decomposing problems, dividing them to simple programming steps that we can make and that the computer can follow and complete a big problem. All right, so there are key ideas in every programming language. And the key ideas that we're just going to look at first of all are sequencing, putting instructions in the correct order, selection. The computer can choose different options depending on conditions present in your program, and iteration. Tasks can be repeated multiple times by the computer. So it doesn't matter which programming language you're looking at, it's always going to involve sequencing, selection, and iteration. Put everything in the right order, let the computer make choices depending on conditions, and repeat steps that have to be done many times. Computers are really good at doing that. To this end, there are some basic instructions that will appear in every programming language. You're always going to have input. There's always going to be some way to get data into your program. You're going to have output. You've got to be able to show the result of these computations. Maths. Computers are great at maths. There's always a way to perform mathematical operations. Conditional execution. Is it the right password or the wrong password? Is it somebody under the age of 15? Is it somebody over the age of 15? Do different things in different circumstances. This is conditions. And as I say, we're always going to have a lot of repetition. Computers perform the same tasks many, many times. They're very good at doing that. So bringing us on to Python. Python, I think at the time of recording, 3.7 is the latest edition. But generally any version 3 would be fine for this. Python is a powerful programming language. It's a high-level language, and it has lots of different uses. It says web development here, but it's a great scripting language. You can do lots of things with Python. Its design philosophy emphasizes simplicity and code readability, and its syntax allows programmers to express concepts in fewer lines of code than would be possible in languages such as C. So really, it's simple to use, it's readable, it's got a syntax that allows you to write quite complex programs quite quickly and easily. It's a great beginner language. The language provides the constructs intended to enable clear programs on both a small and a large scale. So you can do quick, simple programs, you can do quite advanced programs with it. It's free, it's open source, it's got a community-based development model, so you can find it on many different systems. All right, Python is a really great language for learning programming, but it's also useful if you're a more advanced programmer as well. It's very popular. So if you look here at some evidence, why do I say it's popular? These are some graphs by The Economist magazine, based on web searches for different programming languages. So you can see that worldwide here, Python is the 4th most popular language worldwide. And you can see that has gone up a lot in popularity in recent years. And if you just look in America, it's actually the most popular programming language based on web searches, recently overtaking Java. This is another graph. This is from Stack Overflow based on question views in World Bank high-income countries. If you don't know what Stack Overflow is, you'll learn. Stack Overflow is a website where people discuss programming questions and issues. So if you're not sure how to do something in Python and you go to a Google search and you type in Python, how do I do blankety blank? Most of the search results come back will probably be from Stack Overflow. But you can see here very recently, Python has become the most popular language on that website, overtaking other languages such as JavaScript and Java. So of course, all the languages on this list are really good. JavaScript is great. Java is great. Java is what I studied when I was at university. Good language. C# is really useful. You got C++, which is really powerful. PHP is used a lot of web development materials. Again, they're all good languages. We're just taking Python. It's nice, easy to learn language, and it's very useful and very popular. So to program in Python, we like to use some special software, what we call an IDE, Integrated Development Environment. And this is just software that allows us to program easily, that gives us some tools to make it a bit more pleasant, a little bit more simpler to use. You could use any text editor really, you could write it almost directly into your command line, but using a special piece of software just makes it a bit more user-friendly. There are lots of these IDEs available that you can use with Python. We're going to use a special one called idle, and this is the one that comes with Python as standard. So if you download the Python programming language onto your computer, it will come with idle. So it's not the most powerful IDE, it doesn't have the greatest range of features, but it's free, it comes with the programming language, and that's the one we're going to be using. If you want to use a different IDE, that's fine. It just, the screenshots and things will look a little bit different. Okay, so when you first open Python idle, the icon will look something like this. Often it starts in what we call shell mode. And this allows you to write programs one at a time. You write one command, you press enter, it runs it. You type in the next command, it runs it. But this is not really what we want. We want to write the whole program and run it in one go. So you might need to reconfigure it. To do that, go to Options, go to Configure Idle. If you want to, you can change things like font and size. But really, I'd like you to go to the General tab and then select Open Edit Window, close it, reopen it, and that'll give you something that looks like this. That means you can just type all your program in one go, save it, run it. All right, let's look at a very simple program. Print hello. So open up the window, type it in, press F5. It'll ask you to save it. Save it in somewhere where you know where it's going to be. Give it a sensible name like hello or first program and run it. What's going to happen? It's going to open up the shell window, it's going to run it, and it's just going to display the word hello. Very simple. Congratulations, you're a programmer. If you can do lots of instructions like that together, you're going to write really nice, complicated programs that are going to be a lot of fun. So what should you do now? Change it. Change the text. Change your own message. Maybe add another print line. For example, print goodbye. Okay, my handwriting's really bad. That looks abysmal. And then run it, see what happens when you have two lines. When we're doing programming, you've got to experiment, play with it, see what you can get to happen. Try and break it. See what happens if you make a mistake. It's all about experimentation. But if you look at that very simple first line here, you can already see some features that you need to know about. We've got a keyword here. That's print. This is a special word that the computer understands. Python idle makes it display in purple, so we know that it's a keyword. So if you type in a keyword, it'll come up in purple. If it doesn't, maybe you've made a mistake. So we have brackets around what we want to print. Brackets are important. Make sure you open and close them. And then we've got some text. Hello. Because it's text, we're going to put it in inverted commas, speech marks. And that's how we always do text. It's always in speech marks. And it will display in green, so you know that it's text. If you write some text and it's not green, you probably forgot one of the inverted commas, either at the beginning or the end, or both. So again, make sure you get it right. Syntax is very important, and I'll discuss that again a little bit later. So once you've done that, it's a good idea to kind of rearrange your windows just to make programming easier. What I like to do and what I teach my students is that we have the editor on one side and we have the shell in the other, so we can type our code, save it, run it, and it'll display what's happening over here. And that just makes it easy to kind of see them both together, especially if you've got any errors. It's easy to try and do some bug hunting and fix those mistakes. So you don't have to do this. I just think it makes it easier. So in the shell window, which is this one over here, you can type things in directly, like basic math, or you can type in programming instructions one at a time. But generally, we don't want to do that. We're going to write them in the editor so that we can save them and use them later. All right, let's try something a little bit different, something a bit more interactive. I'd like you to type this in, save it, run it. Again, give it a sensible name. Before you run it, it's always a good idea to think, what's going to happen when I run this program? What's going to do? Name equals input. What is your name? Print hello, comma name. Okay, what's happening here? All right, well, we've got some text here, so it's going to display what is your name? Question mark. And the keyword is input. What does input do? Well, maybe it's sending information into the computer. Okay. And where is it sending that into the computer? Well, maybe we've created this thing called name. Technically, it's called a variable, but we'll look at that later. And we're going to, whatever they type in, we're going to store it under name. And the next line, we're going to print out some text, which is hello, and then comment name. So maybe whatever the user has typed in here that was stored in here is now going to get printed out. It's going to be output. All right, that's what I think is going to happen. So I'm going to run it and I'm going to see and check. So again, programming is all about experimentation. You also have to try and guess what things are going to do, have a think about it, run it, see if that's what really happens. If not, think about why. So again, maybe save it as hello.py or something similar. Again, you can press F5 to run it. And something like this should happen. So we've got the text, what is your name? The user types something in, Bob McBobby, not my real name, by the way, and it prints out, hello, Bob McBody. Bobby. McBody? McDoddy. Okay, I can't speak at the moment. But whatever the user types in here is what gets printed out here. Run it 2 or 3 times, change the name, and you'll see it'll keep printing out different things. Okay, this is a good time to talk about syntax errors. So, unless you are some sort of superhero with magical powers, it's very difficult to type in programs without making a mistake. Even experienced programmers, when working on programs even more than 10 or 15 lines of code, tend to make little mistakes. And these produces what we call a syntax error. Computers are very literal. They do exactly what you tell them. They can't guess. So if you make a very slight mistake, they're not going to understand it, and you're going to get some sort of error message. And that's not the computer being mean to you, it's just the computer saying, I'm sorry, I don't understand. Could you say that again? Okay? So things like the colons, the brackets, speech marks, apostrophe, spelling of keywords, it's got to be perfect. It's not like if you're writing an English essay and you forget a capital letter or you forget a comma. You might not get such a good grade, but everybody still understands it. Programming, it's just not going to work. So you've got to make sure you're very careful with how you type things in. So although we understand it, if you make a minor mistake, the computer will not understand it, and you're going to have to check it and fix it and run it again. But don't worry about that. Everybody makes mistakes. I make silly errors all the time. It's okay. So an IDE like Python Idle has different ways of trying to help you understand if you've made a mistake. One simple feature that Idle uses is color coding. So I've already mentioned that. Things like the keywords will be in purple. So if you type in, for example, prit instead of print, it's probably not going to appear in purple because that's not a keyword. So you can see straight away that it's wrong. In the same way, the text should appear in green in Python Idle. So if you write some text that you want printed out exactly and it's not green in the editor window, that's probably because you made a mistake with your inverted commas, your speech marks. So again, you can kind of tell if you've made a mistake as you're typing it. More powerful IDEs have even better ways of detecting and showing you that you've made an error. But Idle is quite simple, but color coding is still a good feature. So again, we've got to use the correct syntax. Print hello works. However, print hello or print hello here, this one's got no brackets, no speech marks. This one doesn't have the speech marks. Neither of these will run. You'll get an error. It's also case sensitive, especially for things like keywords. Print hello works, but print, P-R-I-N-T, capital letters, will produce a mistake, an error message of some kind. Okay, so that works, this doesn't. So be careful. You need to learn to be able to spot and correct common syntax errors. If you're doing this at home, then you've got to do all this yourself. If you're doing it in the class, you've got a bit of help. But what I tell all my students is if you get some sort of error message, it's not that the computer is broken, you've probably just made a mistake. And it's usually something really simple. So check your code carefully. Check it again. Maybe check it a third time. Again, it will almost certainly be something very basic that you've forgotten. It's usually not a big mistake, usually something very small. If you're doing this in the computer lab at school, please ask the people on either side of you. Ask somebody who's better at programming to take a look at it. Of course, you can ask your teacher, but please remember, oh, my pen seems to be going a bit funny there. Oh, okay, never mind. Please remember, your teacher's really busy. You're going to have lots of students in the class with questions. Make sure you've done all these steps first before you ask your teacher, just to make sure they can make most efficient use of their time. Okay? So here are some examples of some syntax errors. This is a really basic one here. You see there's a mistake over here, and it's coming up. You've got a syntax error, invalid syntax. And straight away we can see that this text is not in green. That's because we forgot our inverted commas. So, okay, that was our mistake. I need to go back, change that, run it again. All right, I've run another program, and I'm getting a traceback error. Ooh, it doesn't even... So it doesn't even do what? Well, it doesn't run because there's a mistake. So it started to try and run the program. There is a problem, and it comes up with a traceback error, which is saying, help, I don't know what you're saying. I don't understand. Please say it again in a way that I will understand. And it tells you which line of code the mistake is in. And then it tells you the line that the mistake is in as well. So name minus input, what is your name? Oh, well, it's not a minus, is it? I meant to put an equals. Should be an equals in there. I just made a mistake. So there you go. It's trying to be helpful. It tells me where the mistake is. It gives me the line so I can go back and fix it. So that, of course, is an equals that should be in there. I can go back to my main program, change it, run it. It'll be great. All right, let's try one more program. This one's a little bit more complicated. First of all, take a look at it. What do you think is going to happen? Well, tell me. Oh, I can't hear you, obviously. Okay, so we're going to print out welcome. We think that's probably pretty simple. Calories equals input. How many calories have you eaten today? Well, we know what input is. It's when we want to send information to the program. We can type it in. It gets added to the program. So the question is, how many calories have you eaten today? Okay, we'll type in a number, and then that's going to be stored as calories. Cals left equals 2,000 minus int calories. Well, we got the minus here, so this is probably going to be some kind of math. 2,000 calories minus whatever the user typed in earlier. Okay, that's fine. Why does it say int here? Oh, that's a bit of a new one. Okay. Come back to that in a second. Print you can eat cals left more calories today. So it's going to print out this text exactly. And this text, well, that's whatever the result of this calculation is going to be. So that's how I would try and work out what it means step by step. Then I'd run it and just check that's what really happens. So we'll come back to this where it says int. And this is because when we type something into the computer, for example, at this stage, the computer always thinks that it's text. But now we want to do some math. We can't do math with text. We have to tell the computer, hey, this is an integer. It's an int in Python programming speak. It's an integer value. It's a number. So now you can do math. If you don't say int calories, it's going to be a bit weird because it's going to be 2,000 minus text. That doesn't really compute. So we run that. Yeah, it says welcome. How many calories have you eaten today? I typed in 789 and it says you can eat 1,211 more calories today. So I'm going to go get a tub of ice cream. So again, try it, run it a few times. Any syntax errors, keep trying it again. Here are some extension programs you can try. Don't have to do these. I'm not going to put up the solutions, but if you want a bit of practice, create a program that will work out the area of any triangle. Remembering the formula, the area of a triangle is a half times the base times the height. So you'll need to ask the user to type in two values, the base and the height. So you'll have two input statements. You'll need to do some maths. So you'll need to multiply the base and the height together and then divide it by 2 or multiply by 0.5 and print the result. Next extension, write a program to work out how many days you've been alive for. So this program would ask the user to type in how many years old they are, what their age is, and then it needs to take that number and multiply it by 365 and print the result. So have a go at that if you want. If you can't quite get all that working just now, don't worry. We will go through some more complex programs in the next lesson.